Thanks for joining us. Welcome. I'm Drew Pullum, business analyst for High Desert Traffic. This session is State DOT Solutions for Syncing Data and Linework with Jackalope. We have some presenters from Iowa, Kentucky, Missouri, Utah, and Wisconsin. Even if you're not using roads and highways currently, if you are considering a new GIS system, I'm hoping there will be some value for you here as you hear from our presenters and some of their challenges and accomplishments thus far. So how this session came to be, the motivation, this is really HDT began activities to build this interface between Jackalope and roads and highways based on user input. This really is a result of the feedback and discussions you guys have had with High Desert. Those of you using or moving to roads and highways or considering a new GIS system really saw the opportunity to automate some of the processes and increase efficiency, building a better understanding how Linework and data changes are made between the enterprise GIS system and various program areas. So I've learned so much about what some of you all are doing when it comes to updating data and Linework changes with your system since we started this endeavor. I sincerely have to thank all the presenters, as well as Susie with High Desert, Mark Hansen and Noah Fector in Iowa, Ramsey in Kentucky, and others for their time and hard work helping to put this thing together and taking the time to explain and re-explain things to me until it made sense. There was a lot of crayon drawings that Drew needed. So much appreciated, and thanks guys. I didn't realize all of the complexities and challenges, still don't, that DOTs face when it comes to an enterprise GIS solution. Determining how to make the best use of data available at an enterprise level, where to store it. You have different program areas that have their own area of expertise. They have different responsibilities, resources, requirements, and needs, and the solution needs to be so multifaceted to work. It was a lot to take in. Okay, let's see, that did not do. So the approach to this session, we selected states with different GIS solutions so we'd have a decent comparison. Some had in-house solutions, vendor solutions such as Esri Roads and Highways and Exor by Bentley. And we also collaborated with states by virtual meetings, go to in-person meetings with WisDOT, as we're here in Wisconsin, I am, and on-site at Kentucky and Iowa. And the on-site and in-person meetings were, as it usually is, were really beneficial. It was really nice and helped me to grasp things much quicker and easier. But I also enjoyed getting to chat with you guys and learn things about your states and other things about your departments, which, I mean, not necessarily specific to this, but it was something that I've been missing for a while due to travel restrictions. And I know we all wish we could have been here this year, but it is what it is. So we will have Iowa Jorge presenting, and I will turn it over to Jorge if he's good to go with that.
Yeah, I'm good to go.
Okay.
And Drew, I'll monitor the chat window because I think we're waiting until after all the state presenters go.
Yep, I forgot to mention that.
Yep, and so then, go ahead.
Okay. I was just gonna say, if you wanted to make Jorge the presenter, we could. I think I will present for.
If you stop sharing your screen, Drew, then we'll see everyone's names. When your screen is shared, it's very difficult to tell who's in attendance. So if you stop sharing, and then now we can make Jorge the presenter. I'm looking for him. Got it. Okay, Jorge, you should now be presenting.
And as Jorge is getting ready, I am going to monitor the chat window and we'll be capturing all the comments. and we'll wait until the Q&A session before we get to that. So if everybody wants to just throw their questions in the chat, feel free to.
Are we good?
I definitely
Yes,
see your screen, and I heard you, so I think we're
Okay,
good.
yeah, so hopefully we don't have the glitches. So as mentioned, my name is Jorge Zamora. I'm the traffic collection and processing coordinator for the Iowa DOT. I've been in this position now for approximately 16 months. So bear with me as I'm still kind of new at this traffic data collecting. What I'm sharing with you right now is our Iowa DOT homepage. If you navigate to the center banner there, the travel, if you ever want to look for our traffic information, you can click on the plan ahead there link, and that'll take you to several other links, and that'll take you to our mapping pages, and there you can find our traffic information. So several years ago, Iowa DOT reorganized, and as a result of the organization, the DOT has been divided into 6 divisions, the Transportation Development Division being one of them. Within that division, there are 6 bureaus or offices, as you can see here, the 6 listed. I want to talk about systems planning, which is where my team resides, our traffic team resides. Systems planning is responsible for the traffic monitoring program for the Iowa DOT. In particular, systems planning has several teams, one of them being the cartography and traffic team. So the traffic team, which I'm the team lead, we are responsible for the short-term traffic count program. The other team within systems planning is modeling and forecasting and telemetrics team. The telemetrics team is responsible for the continuous count, our ATR program, continuous count program, and that includes the weigh in motion sites. These are the counts that, as you know, operate 24 hours a day, year round. They provide us with VMT reports, ATR location maps, and they also provide us with our year and factors for our traffic. Within the Transportation Development Division, the other bureau that is a part of our traffic team is the Research and Analytics Bureau. The Research and Analytics Bureau is responsible for our centerline inventory. They do our Iowa Linear Reference Data Centerline, what we refer to as RAMS. RAMS is an acronym for our Roadway Asset Management System. This is our version of Arnold, the roads network of linear reference data. So when you hear me say RAMS, this is really our, roads and highway version. This is our in-house version of roads and highway that we maintain here at the DOT. And again, this slide here is just showing the systems planning traffic team. We have a team of 10 that maintain our short-term count collection, and the traffic and modeling telemetrics team, they have a couple of guys over there doing the telemetric side, and we work side by side gathering all our data. And so how we're set up, what you're seeing here on our screen is our event editor. This is a Esri map product, custom application for DOT. This is where our traffic data resides. So the traffic data is downloaded from Jackalope to our event editor. This is where we do a lot of our QA, QC on our data. What you're seeing here is our network of center lines. Now, this is not our RAM center line. This is just our version of our own center line collection. And this is where you can see where we're doing our QA/QC. Some of these numbers that you're seeing, we have some AADT numbers there. That 6,700 is AADT on that line segment. These call outs are the manual count stations with turning movements. We have a station location, that's the top number, and then also you have breakouts there into our passenger vehicles is the top number, that's 7080. Then below that we have our single units, and then and then the combo units below that. So this is where we do our QA/QC. From there, it gets pushed out into RAMs. And this is what our product looks like. This is our ArcGIS online version of RAMs. It's our centerline road segments with traffic data volume. This map displays essentially 118,000 miles of directional travelway with our AADT volumes on it. And the different color codes there represent different traffic volumes. So the red is 5,000 more AADT, et cetera. Some of the gaps are you seeing is just because of the scale of the map right there that we're zoomed out quite a ways. But if you zoom in, you can go into a really small area and you can see our local road systems. You basically just zoom in, you find the road that you're looking for, you click on it, and you'll get a diagram box that gives you our AADT on that. Additionally to this, if you go to our traffic collection tab up on the top, that'll bring you to our continuous site map. These are locations of our approximately 176 continuous sites, continuous count sites. The blue ones are just continuous count sites. The orange ones are continuous count sites with WIM or way in motion. As I mentioned, we have approximately 176 locations. The other thing I want to note with this map is if you can see our state is divided into 4 quadrants that are color coded. When we do our short-term count program every summer, we will concentrate on one particular quadrant of the state. So in 2021, this past summer, our efforts were concentrated up in Northeast Iowa. And it's on a 4-year cycle. So next summer will be Southeast Iowa. And then the summer after that, we'll be back into Northwest Iowa. So every 4 years, each of these quadrants will be counted for our short-term counts. So some of the considerations for selecting, our roads and highway, what were some of our stakeholders, what did they have at stake? So as I mentioned, the different divisions within the IODT, they all have a role in RAMs. They all contribute to data that goes into our roadway inventory. The traffic program was just one area of the data that was implemented into it. So the decision to go to roads and highway was not our decision, but it came from the research and analytics. And through that process, they met with all the different stakeholders and said, okay, this is what we want, this is what we need, and we moved on from there. And another consideration was, how is this going to work systems performance-wise? Our old system that got replaced took a very long time to load, to load up into whatever interface you're working on. So if you're doing a GIS and you wanted to load up our old roadway inventory, you would load it. You could walk away from your desk and come back, a half hour, 45 minutes later, and it was still loading. So systems performance was an issue. Another issue was planning, strategic planning. This new system, our RAMS, has to handle approximately 118,000 miles of directional public roads. And that RAMS is used for quite a few business decisions at the DOT. One of the biggest users of it is our management division, which has a tool called the project prioritization tool. And it uses RAMS data to prioritize projects within our 5-year program. And it looks at all these different criteria along a corridor, whether it be pavement type, pavement surface type, pavement width, shoulder type, shoulder width, and I think there's even environmental data that's associated with it. So this tool is used to prioritize our projects within that 5-year program, and it prioritizes them in in order which projects float to the top as far as which ones get worked on. Some of the challenges that we faced, different areas of DOT have different linear referencing descriptions. Some offices use lat long. Other offices use milepost descriptions to describe a location. The design office doing roadway design, they use stationing. I've also seen literal descriptions on project concept statements. All these different naming conventions or site locations had to come together to work seamlessly for us to be able to transition into our RAMS environment. There was also coordination with multiple database structures, different feature classes. So you can pull up a center line and see all the different key attributes to that center line. You can toggle off and on what you want to see, and these were added from the various offices at the DOT. How did this work with our traffic data? The system had been in place for quite some time. We had an older system. Our centerline database had traffic data in it. Like I said, it used to just take a long time to load up. I believe that with our new RAMS, this works a lot quicker. But one of the things that was challenging for us was the old system. All our traffic data was maintained on a single center line. So if it was, if we had a divided highway, that was represented by a single center line. With our new system, divided highways had a center line in each direction of travel. So making that transition to import the data from one center line to 2 center lines on a divided highway was a bit of a challenge. We still have a few disconnect areas with that, but for the most part, I think 90% of the time it is working for us. That 118,000 miles of roadway data that we have, that includes travel weight. So what that means is a divide, Interstate 80, 1 mile of I-80 actually has 2 miles of travel way on it based on the 2 center lines. So this is, we met with HDT, and this is our high-level graphic planning diagram that we used to come up with our presentation. But in a nutshell, as I was talking earlier, all our data exists in our Jackalope storage. Phase 3 is completed, and then once that phase 3 is completed, that's when it gets pushed out into RAMs, and we're set to do our AADT and publish our we update our online interactive map with that. So this is the same thing, a little bit more detailed. As mentioned earlier, once phase 3 is completed, it is sent into Jackalope temporarily. Our IT department then runs an SQL. What that does is create tables with our data, and it makes it available so that we can look at it, in a GIS format. From there, it goes back into our event editor. We do our QC, QA. We start annualizing our traffic volumes. Once we get that done, it goes back, in event editor, it gets finalized, and then it gets pushed out into RAMs. Once RAMs is completed, then we get set to start doing our HPMS submittal. As that diagram shows, right now for Iowa, the push is from Jackalope to RAMs, so we do not have a Jackalope to RAMs dialogue yet. At this point, we're just kind of in a wait and see what's going to happen for us. We do foresee Jackalope and roads and highway just having more of a role for us. But like I said, right now, we're just kind of more in a wait and see what's going on with this. And so that is our presentation.
Again, while the next state is getting ready, there are some questions, or one question that I will put into the queue. And then Stephen did have a comment. Thanks to Iowa for sending in your TMAS data, the 27 WIM sites in 2020 and 107 class sites.
I will take presentation. I will present for Kentucky.
Oh, okay.
Can everybody hear me?
Yep.
Okay, I was hoping here in the office there wouldn't be any lag like there is at home.
Could somebody make me presenter, por favor?
Do I have to do that, Drew, or?
I just did. It should have changed.
Let's.
Oh, here, maybe it didn't take. Oh, you're in twice. That's the problem. Okay, hang on. Now, yeah. Can I dismiss your other entry in here, Drew? Maybe there's a problem. Okay.
And before we move on, Tom from Wisconsin had a question for Iowa. He asked, do you store traffic segment data in Jackalope or just sites?
we do have some traffic segment data in Jackalope.
Okay, I think we're good to go. Melissa, if you're ready.
Okay, I'm ready. Hello, everybody. I'm Melissa Brown. I work for the Kentucky Transportation Cabinet. And the first slide is just our homepage for our website for Kentucky Transportation Cabinet. Drew, you can go ahead. So traffic counting is housed inside of the Division of Planning in Kentucky. And this is the organizational chart for our division. Sean and I and Crystal, who retired earlier this year, worked for the Traffic and Equipment Management branch that's circled here in yellow. Crystal's job is vacant. We have a new branch manager. His name is Robert Brown, and he's not with us today in this presentation. We also have an equipment management team, which is our field crew. They have a vacant position too. There's normally 4 of them, but right now we only have 3. They perform all maintenance on our ATRs, perform our district training. They certify our counters every year to make sure they're functioning and ready to go back out on the road. And they take care of installing permanent sensors in the roadway with contracts. I process all of the continuous data for all ATRs. Sean does portable counts for half of our state. Right now he's doing Crystal's load too, so he's overworked. And we also work very closely with the branch that is highlighted next to us, data management. That is where HPMS is driven from. They actually own and take care of the entire HIS system, which is XOR. The two are kind of interchangeable when we speak, and that's what I'm going to talk about today. You can go ahead. Well, I didn't go into the rest of our breakdown, sorry. We have 12 districts that perform our traffic counts for us every year. We count about 5,000 stations a year. We have 15,500 portable sites that we count on a 3-year cycle, and another 4,500 bridges that we count on a 10-year cycle. We have approximately 100 ATRs. Of course, it varies how many are working from month to month. And we have a statewide contract that we utilize to fill in the gaps of anything that we can't collect if someone retires, someone gets sick. And they also perform the ramp counts inside of our largest district. Since we count 125 ramps in District 5 around the Louisville area every single year. So in the 90s, back in the 90s, we're going to go way back here. In the 90s, KYTC had 3 separate systems that they were maintaining in separate databases, but they were all linear, loosely based on a linear network with mile pointing, but they weren't the same. So in order to bring all the systems in line, in 1992, they decided they would hire Oracle to come in and create a database of all the highway systems. In 92, it moved into production and everything started loading its system into there. So we have OMS, Pontus, Jackalope. We have a lot. So we still have external systems, but we have one large HIS system that encompasses all highway data. HIS is also known as the Highway Information System. Okay, you can advance. So in Kentucky, we have 80,000 miles of roadway, and inside of our database, we keep all 80,000. There's about 46 different assets inside the database. They are pavement, functional class, lanes, medians, traffic, everything's in there, shoulders. Back in the late 90s, early 2000s, we began to move into a GIS-based system. We began collecting all centerline roads for all 80,000 miles. So we had staff here in central office that went and drove all 80,000 miles, gathered the centerlines, and then they were loaded into our database. After that, we began moving into a spatial system, and XOR was the best fit for that because we already had an Oracle database. I don't know if many people know this, but XOR actually stands for ex-Oracle employees. So it was some employees that had broke off from Oracle and started their own company to move transportation data into a GIS-based system. Okay, you can go ahead. So the official order, the way we do official orders hasn't changed. This is an official order that's sent out where roadways have changed. And as you can see, this is dated in July 12th of 2021. So part of the reason that we needed to move into a more up-to-date system was, go ahead and advance, Drew. Oh, go one more. Sorry. This is the map and notification email that went with the previous official order. The roadway that was realigned in that official order was actually completed in 2019. The actual final paperwork to change ownership of all the roads was not completed until 2021. Now go back to the one that was before us. I'm sorry. So the problem in Kentucky was the roads built, and it takes months, years to get the official order signed so that everything can be done. The problem was without that roadway inside of the GIS system and inside of HIS, there was no way to charge snow removal. There was no way to charge mowing along the road. If there were accidents, there was nowhere for the state police to locate them. So we began changing our road network as roads were actually built. We send a crew out to actually draw the center line every single time a road is built, realigned, or changed. There are two guys from the field here that'll go out and drive that road, and they will take the center line, and as they come back, they will draw it in. Go 2 slides forward. So in XOR, as we change a road, we will draw in the new roadway, and we will transfer all the data off of the old roadbed onto the new. We do this with a temporary route placeholder so that we don't actually lose information. And then we have 3 employees here in central office that will take every one of the data items, all 46 of them, and make sure that they are where they're supposed to be along the road. After that, they will notify traffic, bridges, anyone else who is a data owner of the changes that they've made. And then I will have to go in and make sure that traffic is where it's actually supposed to be. So inside of XOR, traffic has 3 inventories. We have TF, which is our line item. We have a point file, which is TS. And then we have some children records of TS that are TSAs. Every time Jackalope gets a count for a given year, a child record is written out to XOR. Go ahead and scroll down. So basically, ours is a lot more messy than Iowa's was. So the reasons that Kentucky went on and went with XOR instead of someone else was there wasn't a whole lot around, of course, back in 2002. We already had an Oracle database that housed everything, so it was a seamless process to move into XOR since it was an Oracle database. Overhead here in Kentucky likes to say that we have a database with a lot of highway information that has a spatial capability as opposed to something that's spatially driven that has a little bit of database functionality. Another reason that we went this way was XOR is based on datums. I think roads and highways is about to move to datum-based assets, but when you move things on the datum, you don't have to realign a road and make changes to the entire roadway every single time there's a small change in, say, the middle or the end of the road. You can go ahead. All right, so how our workflow works is we are down here at the bottom in the traffic branch, and we will process all of our information through Jackalope. So in order for a site to exist inside of Jackalope, it has to actually exist inside of XOR first. So every single week, we push a site table over to Jackalope. It can be done more frequently if needed, but I try not to do it and just let the system do it on the weekend. We do not push data back into XOR until the beginning of next year, when all the traffic statistics are ready. So the communication back to XOR, it happens once a year. It sometimes happens more times a year, but they're all right there together, and it's all for the HPMS submittal. I don't use the HPMS validation inside of Jackalope. We push data out to XOR, and then we push it through tests to get validation back there. And then we do most of our validations inside of there instead of inside of the Jackalope program. We also push data out once it gets into XOR. It pushes out to Bridges. They maintain through another system called PONUS. It goes into the TED, which is the Transportation Enterprise Database. There are lots of systems that look at our data through there. The project information form for the 6-year plan, what Iowa was talking about, where projects get weighted, that happens through TED. So we put the data there once a week, where not much change happens, of course, except for site locations and new roads. But once a year, we will push out all the yearly statistics from the year before, and Bridges will get them for their yearly submittal. Railroads pulls them. There are lots of people probably behind the scenes that do. They don't have to notify us that they're using our data once it's there. We don't actually have a public database through Jackalope. We let everything go out through the HS database and through TED. Okay, scroll one more. This is our website where we house traffic counts. We have our own in-house interactive statewide traffic counts map that anyone can use. We have a traffic count database that shows all the history of each site and the truck percent. It has a nice little graph, and it tells more about the length of the traffic segment instead of just the point. Then we have traffic count extracts. It's basically just an extract of the data as you would get it out of traffic. So if an external user wanted to get a traffic shapefile to use in their own map, they can get that there. And then we have a little bit of extra information that forecasters and other people, consultants out in the public will use. You can scroll one more. This is a picture of, it's a really zoomed out picture of our interactive map, and we've selected a route, and you can see the route information, the begin end mile point on the segment. The one we've selected is actually a ramp, and the ADT is listed there, the truck percent, K factor, D factor. That is just the traffic inventory showing up. You can actually, there's several pages there, and you can see other inventory items. If you keep going through there, you would be able to see lanes and functional class and any other layer that's attached to this map. Okay, scroll one more. And that is, if you zoom in, you can begin to see the ADT We have the ADT, and then in parentheses, the year that the traffic was collected. We have the total truck percent instead of just the single unit and combo. And then we have the station ID for the site that we are looking at. And then there's more information listed over at the side that'll tell you the ADT for the trucks and the single and combination units broken out. Okay, scroll down one more. So where we are now is we're about to migrate into asset linear referencing system. I've heard people pronounce that, but I don't know how they say it, which is the next piece of software from Bentley. We are right now, because we are using Spatial Manager, we are using ArcMap 9.3, so we are really behind the times. We will be moving to 10.6. We were supposed to before COVID. There was no way to get us training, so we'll be doing that, I guess, sometime between now and the end of the year. It's going to be more web-based, so it's going to be a little bit of a change, kind of like when Travis moved into Jackalope. So, and that's all I've got.
Thank you, Melissa. Next up, we have Spencer with Missouri. If you're ready, Spencer, take it away.
All right. Can everyone hear me?
Yep.
I can hear you.
Can someone make me the presenter so I can share?
I'm looking for you on the list. Just a second.
While Catherine is doing that, Jorge, there were just a few questions for you. Tom, you answered Tom, but Margaret had a question for you about how does Iowa reconcile centerline on divided highways for HPMS?
Our centerline data inventory, that is updated by our research and analytics department. So that's a totally different office from us. So that was the other area that I highlighted at the beginning. So they're the ones who do all the reconciling for the HPMS submittal. So unfortunately, I can't answer that question.
Okay, we'll hold that then, and because it looks like Spencer's ready.
Everyone see my screen all right?
Yes, I can see it.
Oh, okay. So my name is Spencer Robinson. I'm a transportation management system administrator for ODOT. Next slide will show you just kind of a breakdown of our transportation planning department. It consists of 3 major areas. The planning and performance section coordinates with our MPOs and RPCs to coordinate their needs with projects, and our statewide programming section eventually puts those projects into our 5-year statewide transportation improvement plan, or STIP. And then my favorite section is circled in red there. That is our system analysis section, which collects data on the condition and use of MoDOT roads and provides this data in a convenient format for the rest of MoDOT and customers. Zooming in a little bit, you can see that our system analysis group is split into 4 groups that all rely on each other to deliver data to coworkers and customers. Our pavement analysis and application development group maintains our baseline work and updates the line work based on input from districts, MPOs, RPCs, aerial imagery, our crews out in the field, and any other method you can probably think of. My group is the traffic collection group, which is circled in red on this one, which consists of our field crew, our in-house field crew, which collects traffic and pavement condition data to be processed and checked for quality by our staff in the office. This also includes all of the data for our short-term and continuous count programs. We also have a data group, which, I mean, they handle 1,000 different things, everything from route ownership to speed limits, striping, pavement types, shoulder information, functional classification of roads. And they are also in charge of our HPMS data submittal. And then our last group is our mapping and customer service section, which answers questions about our data from users and customers. They determine certified mileage of every county, create and print our state map every year, and provide customized map for the many different data requests that our department gets. All these groups work together to maintain our data in our in-house transportation management system, or TMS. TMS currently has three primary components: data inventory, report generation capability, and data analysis capability. And these components are embedded within 6 modules that focus on our pavement management system, our bridge management system, traffic management system, safety management system, travelways, and our state of the system. Our traffic data is pulled from, we only store sites in Jackalope. We maintain all of the work on all of our roadway segments in TMS. So at the end of the year, we pull our traffic data from Jackalope and distribute it out to all of our traffic segments, to the segments that the sites live on, and then out to all of our additional segments that don't have sites on them, but are grouped with segments that do have sites. And that, an example of one of the applications that we put out there with all of our traffic data is our online interactive average annual daily traffic map. It includes ADTs, AAWDTs, vehicle classification data, peak hour volumes, and hourly traffic data. Users can also change the year in the drop down over in the legend and look at data on all of our line work back to 2016. For 99% of the requests that we get for traffic data, this map satisfies their need. We have a ton of other applications out there through TMS, including ones that allow our maintenance crews to set up work zones and time road work to have the least impact on users. This next slide, we'll start getting into how we update our line work data, looking at Drew and Susie's crayon drawing of our line work change process. So in Missouri, we update our TMS line work every quarter. So we go through roadway realignments, new intersections, any other, new construction, any other changes you can imagine. We start off about a month before our quarterly maintenance period with a meeting with all staff who are responsible for maintaining the line work leading the meeting. They identify what changes are going on, provide all the users who will be updating data on these line work changes to ask questions and ask questions about how it will affect data. Areas with a major change, for instance, adding a new interchange, changing a 4-point intersection to a roundabout. They'll provide visual examples that I'll show you here in a second to give us kind of a heads up and start to pre-plan how we're going to fix our data in these areas. We do quality control checks before maintenance starts, where we can see the new line work in a test environment and try to fix any gaps or missing data before our maintenance rolls out. We have an in-house orphan tool that we have built through ArcMap that allows us to identify missing or misplaced data. You'll see old line work and new line work. And then we have other in-house applications that allow us to actually add and edit data. So I'll show you. This is a pretty simple example where, we had, a 3-point intersection that was changed to a roundabout. This doesn't take a ton to fix. We add a new segment at each leg of the roundabout, copy traffic data from the adjoining segments. Other groups have to update functional classification and other data that goes along with these segments as well. A slightly more complicated example. Still, this is just a 4-point intersection with a free right turn coming south to west that was turned into a roundabout. This is a little more complicated because we have to add segments for each of these little legs that go into the roundabout as well as each little leg of the roundabout, but again, not terribly complicated. Another example, this is in the southwest corner of Missouri near the Arkansas border. Interstate 49 used to end right up here, about 5 miles from the Arkansas border, and then continue southeast as US 71. We have added in new roads through here, a new interchange with, I believe that's County Road 90 down there, and completed it, and should be open as a full interstate either late this year or early next year, with full interstate all the way through Arkansas. Our group, for instance, would have to go through here, add new traffic segments through all of this line work on all of the ramps, enter estimated traffic volumes in case our field crew is not able to get down and collect the data this year, add sites to all of these locations and schedule them so that they can get down and get us better, more up-to-date traffic data in the area. So some challenges we face with this, it's a huge commitment to update our line work every quarter. It takes a lot of coordination and collaboration between many different groups and divisions within MoDOT. It does allow us to have our line work updated as soon as new construction is open to traffic. But again, that takes a lot of coordination on our part to make sure we don't release it too early or too late. We do occasionally find areas where we are not correcting our data as well as we would like. When we discover that, we write what we call inventory validation checks to automatically check through our line work and our data to look for gaps, look for inconsistencies, and automatically identify those so that we can go through and clean those up before our year-end process rolls around. We are running into some challenges with the version of ArcMap that we are running. Some of the newer versions might not make it possible for us to maintain our data within TMS and may need to consider other alternatives such as roads and highways or some other solution to maintain our systems. We sync data manually between TMS and Jackalope, which we do a pretty good job with. I'm not going to say it's always perfect, but we do a pretty good job running that before year end to make sure everything is up to date and matches. There are instances where our functional class data is not the same as in Jackalope. Some of you might remember Chris Rittock, when he was with our traffic group, is now our HPMS coordinator. He'll occasionally run into problems where we have more than one functional class on a segment. And that's just something that our groups have to coordinate and work around and make the necessary changes so that we can use the data properly. And that's all I have.
Okay, it looks like Nicholas is up next. Let me make him the presenter. All right, Nicholas, it should have notified you that you are presenting.
Okay.
I can hear you. Okay, I can see your screen.
All right. I'd go to so I can see my presentation on my other screen here. So just as everybody else, here's our landing page for UDOT. A quick intro about me, a little bit on my background. I started as a temp back in 2003 with UDOT, and my primary job was actually updating the LRS. But at that time, we were using a mainframe system, so I was referring to, poster-sized maps and cabinets full of pages to do the same work that we're doing today. Within a year, I was hired on and moved into the CCS program, and then I moved a couple other positions with the short-term accounts and the annual statistics, and now manage the group. Our division is technology and innovation. We've previously been called program development or systems planning and programming, and recently just reorganized. Within that group, we've got probably about 5-6 groups. And really, I'm only going to talk about two of those here. We've got the 3 that I'm not going to talk about, research, assets management, our road usage charge, or RUC. And the 2 that I am going to talk about is my group for performance and process improvement, as well as our data technology and analytics group. So in performance and process improvement division, one of the main reasons that I'm grouped here is this is where we handle all of our SPR dollars. And so a lot of individuals that are SPR funded from FHWA are all underneath this group. And so we've got, the continuous improvement program, which mostly works with a lot of strength finders, looking, learn from groups and outlining their strength and promoting knowledge management. Then we've got a subdivision of the asset management that's more the FHWA side, where we do the data collection for SCID and IRI, as well as that group handles all of our functional class changes and coordinations with local governments, as well as trying to update our functional class information for our census. And then enterprise risk is just a model-based approach to evaluating our roadway assets. In our group, I work directly under Ryan Bailey, who is our transportation performance management coordinator that works with FHWA. And then we obviously have HPMS, myself, Todd, our truck statistician, and then our CCS crew of Devin and Sam. And a lot of the rest of our work is, we're obviously a much smaller group than many other DOTs, is either handled through ourselves directly or through consultants and partners. In our data technology and analytics division, we've got our business systems to handle a lot of our applications and new system developments, like the Adobe, Oracle, Google Workspace. And then we also have a data coordinator who helps track and document and maintain data across the department, and kind of leads the effort towards bringing different groups together and sharing and developing data to help maximize that information across areas. The data and analytics group here that I've highlighted is the main group that I work with for our GIS to accomplish all of our roads and highways and dashboarding. So at UDOT for roads and highways, our main stakeholders, we had obviously HPMS, traffic, pavement, right-of-way, safety, planning, structures. And while all of these may have layers, not all of them have users. So like HPMS, traffic, and pavement, all are probably or all definitely do have a user in Roads and Highways that actually manages it. Some of the other groups actually rely on our GIS group to maintain those layers within Roads and Highways. For our certified public miles maintained in Roads and Highways, we've got about 14,000 of the 50,000 are actually managed by Roads and Highways on our LRS, and then 35,000 of those miles are actually on our locals that are managed by our B and C roads or the federal lands. And then we don't have calibrated mileage for that because B and C's actually kind of really dictate what those total miles are for their own roads, and many of their the locals aren't in a GIS environment, and so we do use the information from Utah's AGRC for the Linework that's used for Arnold. It's just not calibrated to a one-to-one representation if you were actually to get a calculation from that Linework. Some of our challenges with implementing Roads and Highways is, we had a custom Oracle system written long ago for HPMS and our LRS systems, and wasn't really in a system that could do it in a straightforward conversion. So there was a lot of correcting that database and updating it prior to putting in that information in there. For traffic, it was actually a lot bit easier. 4 years ago, I think I presented at this users conference that basically I had no idea what we were going to do for Roads and Highways for traffic, and thankfully it turned out just turned out to be a really simplistic view of our site table with a few of the current HPMS statistics that it's created for us. And then the last one I highlighted on there was creating business flows for Roads and Highways for each data layer, basically kind of determining, how are we going to proceed with, who's owning what information for each group. So in Roads and Highways, we use Workforce Manager or Workflow Manager for our all of our edits. Originally, we set it up so that we would do individual jobs for every single LRS change that came through every year. The job note would have details for all the changes from the route. So on the right here, we've got notes from the LRS team that says, these 2 routes were changed and went through and how they did it. And truth be told, it actually became too cumbersome for both the GIS group and myself, just due to the nature of how many edits that could happen in a given year. So now what we do is we actually create 1 job per calendar year, and we leave that job open. And so right now I've got like a job open for 2021. I go into the system and I still receive a shared document that still has all the same notes from the LRS team. But I make my notes still in that 1 job now as I update it, and then we can, at the end of the year, we can kind of go back and make sure that we've captured everything with some QC. This kind of creates a few small challenges in keeping layers and builds open, just for the fact that you have revision changes and upgrades that happen on the back end. But the GIS group, Kelly and Peter, are really there that handle that really well for us. So we haven't had any major issues with that so far. I mentioned earlier that not all layers have a user. So like in the mid 2000s, I received a lot of GIS training at the same time as the department started to begin implementing it. So that was kind of the main influence on why I'm an editor and not a GIS person is the editor. Is that I wanted to have that ownership in the role and have less, because our GIS folks don't all have that history and knowledge of what our traffic segments actually mean in the system and how those rules are set up. So for anybody else, if you do have to rely on a GIS person, I would say showing them and teaching them more about your traffic system and your data segments is probably going to be a key goal. One of the things that the GIS group does as well is they create story maps. So they'll go through and actually create a map and tell me, like here's a route that basically got sliced and diced, 5 different ways for 2020. They removed out the beginning of the portion of it. They added a new start point, and then created a new alignment, as well as added in an unbuilt segment and a new section towards the end of it. So this is really helpful when they provide this information, because it gives me some tools to make my decision on how I want to change my traffic segments. So like that first section that is in blue and red, that says it was, the route old begin and alignment removed and unbuilt alignment removed. I had to first make a decision to say, is this a site that I still want to keep in because I have an ADT history for it, or is it a site that I just want to delete and replace? And the decision was to actually delete and replace it, because no longer do I have a roadway going into a subdivision. The new built road is actually a bypass that kind of goes around that subdivision. So from the base data set that we're building in roads and highways, we connect the data to our UPlan and open data portals. And then I also have a Google Earth map that I built years ago, but that's now actually automated and can be updated automatically from our roads and highways layer after HPMS has been submitted. Additionally, we've got on our traffic website, there's a layer out there that connects both of our ADT information, our CCS information, as well as our operations data for all the site information for PEMS. So on the map on the right-hand side of the screen, we've got some circles and squares, and you can see some line work. You click on any of those lines, and it'll give you ADT history from 1990 to present. And then like all those circles on that map is actually our operation sites, and then the squares are the CCS locations. This has really helped us to figure out where we're kind of overlapping some of our data sets and kind of try to see if we can slim them down or decide what to do if both sites need to coexist. And then going into working with Jackalope with roads and highways, last year we had to spend a lot of time figuring out, looking at the Esri API and looking at our traffic segment layer, trying to figure out what was needed in order to share that information with Joe and Susie and Drew. We needed to find information that was available, and so that Jackalope had something to talk to. The data in the public view, was it accessible? Initially it wasn't. So talking to some of our GS folks, figuring out how to make that data available, and then how do those things connect to one another really helped. And then lastly, to summarize everything, some of the lessons learned was, I went from not in the know to having to manage the data regularly. And so throughout that process, all I can say is the 5 W's and H's, who, what, where, why, and how does your traffic program fit in this process. Determining those key stakeholders involved throughout, as well as what stage of implementation your data may be in throughout that process. Why is your traffic data layer broken because of a recent change? All those sorts of things. You just have to keep asking questions and have that line of communication is really, really big. And I think that's what's been really successful for us at UDOT is just we work really well with our GIS group. As far as using Jackalope roads and highways interface, most definitely. I mean, right now we do a lot of manual effort to replicate all the roads and highways efforts to Jackalope. We've probably got around 6,000 records, and when we updated to the new ALRS, every single record had to be updated because we used a new mileage for every beginning and end milepost. So we don't really have the staffing and resources currently available to make all those manual changes in Jackalope. So having an automated process in place that can communicate with that information from roads and highways will really help improve that information and align the data sets together. Anyways, thank you. That's all I've got.
Thanks, Nicholas. Okay, it looks like our next is, it's Wisconsin, and it says Tyler and Rhonda. Who is going to do the presenting?
Drew, would you be able to present for us?
Yep.
With that video.
Okay, so Drew, I'll make you the presenter.
Give me one sec.
And while they're making that switch, I think time-wise, we're doing really well. There have been some questions in the chat window, and some of the states have been answering, so that has been working out great as we're getting ready for Wisconsin to do theirs. And hopefully we won't have any audio issues as we are wrapping up. And some of you are answering. Christy had a question about, are people tracking the number of edits, route edits that are occurring on your LRS during the year? And so we've had a couple of people respond to that. Idaho, Kentucky, and Utah have responded so far.
Okay, let's see. Can you guys see this?
Yes.
All right, take it away, guys.
Hello, everyone. My name is Rhonda. I am the business traffic count liaison lead for the data management section. I've been working in this section since about 2000. Tyler?
I'm Tyler Halverson. I'm a traffic data analyst with the traffic data unit, and I've been with them for about 6 years. And actually, Susie Ford was my chief when I did get on, and it's been nice having her around still.
Next slide. So this is Wisconsin DOT org chart. There are 3 areas that report underneath my supervisor, Tom Reese, and that is the field ops, the traffic data unit, and the highway data unit. Little information, our supervisor, I don't know if he's on or not, but he is one of the chiefs that has a lot of different units underneath him. So he's a little gray because of us, but we try to, balance him out a little bit and make his job a little easier. We had many issues in the past with the different units and how we worked and how we completed our tasks and such. But over the years, we have found a system that works, and we are able to communicate with one another and from different units to complete our business needs and still provide business functions to the other areas like forecasting and other people and our other public requests and so forth. So for the field ops unit, this unit is not located in the building that we currently work in, and that is due to the large trucks and the mass amount of equipment that they have when they're going out in the field. they work with our traffic, they work with our consultants in providing training, and then they also help collect the data for us, make sure that there is no issues out in the field. Person that usually leads the field crew is Russell Lewis, and he's been with us for a few years, and he has quite a few staff that works with him. We also have the traffic data unit, and this is the unit that me and Tyler is part of. This unit is responsible for ensuring that we follow all the rules for data collection that's set forth by FHWA, and make sure that we follow TMG, of course. And in this unit, we collect, process, work with the field staff on making sure that the equipment is up. If we have any issues, we usually work with this by daily emails if we're having any issues. And this unit, we also work with the public to providing GIS requests and just providing just any type of traffic reporting that we can to the public. And then we also have the highway data unit. And this consists of local highway collection of data, and also the HPMS coordinator is part of this unit. In this unit, this is where we have what we call our Wisconsin Information Systems for Local Roads is located, and this Whistler provides a system for the local government to report local road information to WISDOT. The highway data unit also oversees the state and off-state line work changes that occur. And every year we work together, and we work diligently to work together to make sure that we can make sure that I'm so sorry, you guys, that everyone closeout efforts are in place, and that we can all get to the updated information that's needed. Next slide, Drew.
And like Rhonda said, the Wisconsin data management section, specifically the traffic data unit and highway data unit, have collected a lot of data over the years and have developed different systems for their location control management of this data. Within this diagram, you can see the different systems we have developed for location control and line work, enterprise line work control. These are mostly in-house Oracle solutions. And in the center of that diagram, you can see the STN and the Whistler systems, which is the STN is our state system, and it is a DB2 CICS Oracle solution. And this is called STN, or State Trunk Network, and it has 14,000 miles of state roadway. And then we also have another system, which is Whistler. It is our off-state system that is a web-based Oracle solution. And this has 123,000 miles of local and county roads. And highway data unit oversees this and uses the LCM, Location Control Manager, to make certain changes in these different networks, such as segment changes. And then as well, in this diagram, you can see traffic is brought in. Our traffic data unit uses two different traffic systems that we have to manually synchronize. High desert traffic is a huge part of this with Jackalope, and that Jackalope application, which we make our primary traffic edits in Jackalope application, which we then get a copy of the primary Jackalope database as a local public database here for us to use. And we have some heavy hitters from TAFIS, or forecasting, as well as different users that use SQL and pull the data out of there. And Oracle Spatial Data Enterprises is a huge, Oracle and their spatial SDEs allow WISDOT to make connections through these systems that include Jackalope as well as HPMS. SDE is made up of many data views and data tables that the Jackalope database interfaces with, and we can use STN, Whistler, HPMS, and traffic, or combine those different data sets. And through that, SDE WISDOT has combined those data sets and created our ArcGIS desktop application where we can go in and view all these different data sets, traffic data and the highway data, view them all and manage the points and segments and make the right modifications. And that covers that there. We can.
All right. So I think Margaret had a question. I apologize. I'm
Okay.
going to have to stop sharing for 1 minute. My computer does not like me today.
While you're doing that, I think, Margaret, you're just responding to the network edits, the question Christy had.
Guess I did forget to mention one point. Between those two different traffic data systems with Jackalope, we do have to manually synchronize those two different systems. So there's two main sources. We do have our traffic point location and data stored where in the traffic Travis edit tool is at one point location, whereas Jackalope has a different one. And when we make a change, we have to make that change in both systems and confirm in both systems. And that update we will not see for a week because we receive that public data, or that database so large that we receive weekly pushes, ETLs of that data over the weekend. And we'll see that update on over the weekend, Monday, when that first day of the week, work week.
And we're back. Sorry about that.
Okay. Before maps were available online, WISDOT used to publish hard copy traffic count books annually. You can access these historically online still. What we used to do was, this was a very tedious and long drawn out process. We would actually print reports from Travis page, number the pages by hand, and then send books out. Well, first, we would also have to get permission from the section chief and also from the secretary's office to get monies to send the books out to be published from an outside vendor. Then the books would come back into the office where I would have to go through all the books, send them to the library, send them out to our people that purchased them, and also to the staff in-house here, and then send the remaining ones to the maps and publication cells. And we did this for numerous years. And we started off, I want to say, with 4 books we started publishing. And the first book, I do believe, was published around 1975. This process of publishing books stopped, I want to say, around 2011. And then we started publishing PDFs online from 2011 to 2014, where the public can still not get the books, but still get the information that they wanted PDF wise, and we could just provide them with a link online. And then we slowly but surely evolved, and now we're publishing on the web. Tyler? Next slide. Tyler, I can't hear you.
Yeah, I'm just chirping over here. But in 2014, that was around time when we had web-based applications starting to be developed, and I believe it was Chaparral or High Desert Traffic and WSDOT teamed up and created Roadrunner Web, which was our web-based application for the public where they could go and view continuous count and short duration traffic data. But then when Travis went away, we lost those capabilities and had to develop we developed our own web-based application, and we developed a web application that ArcGIS Online application called Traffic Count Map, or TC Map, and it is WSDOT's interactive traffic count map for public use. Pretty similar capabilities as Roadrunner Web. I don't believe it has maybe lost some important functionality from Roadrunner Web to TC Map currently, but hopefully now that we're seeing some of those capabilities coming back through just even this user conference as well as with ArcGIS Online. But with that TC map, if you want to go to the next screen, you can click on our interactive map here within our website, and you can go in. This app opens the application, which allows you to search area, location, addresses, or traffic count site IDs. And specifically, when this app or this view here, we say we search the site ID 131118, and that'll zoom you right to its location and give you its most recent AADT, that AADT date, its county or its location information. Basically similar to a segment, but it would be like, or its location description would be Bluff Street between Palomino Lane and Bridge Street. So that would be the ADT between on that segment. And then you could also go down to a street view. You can click on Street View, which takes you to the Google Maps Street View, and you can view that location from a point of view. And we also have previous data tables assigned to this application where we can go back and see historic or previous counts taken at this traffic count, or all counts taken at this traffic count site location. And allowing that is because we are able to use our Jackalope PDB, where we have Jackalope PDB site and stat, and its source data is Jackalope PDB TC map application. Source data is our Jackalope. We can move on to the next slide, and going back to that limitation, updates are not daily. We see them weekly within that application because we do not receive that or a PDB update till Monday. In the next couple of slides, we'll describe how we do our Linework changes and some of our 9 non-Jackalope site attribute changes.
Next slide. So this slide is an example of a functional classification request that we get from planning. And this is just showing the swim lanes of how, the workflow of how I received me and Tyler, we both received the email alerts from the planning department. And we will go in, make special sites in Jackalope. And then we will also go in and make, in the TET tool, the site, produce the site for location purposes. Then we will submit this information supply this information into the field crew, who will go out and collect this data for us. Then it will come back to the traffic unit where we will process it and have it ready for the planning department to rectify what they say that the new functional class change is supposed to be. And then this other workflow is of the export that Tyler does. Tyler, would you like to explain this? I'm not hearing you. I'm not hearing you. I'm not hearing you.
And I'm on mute again. Here I'm going to go over that weekly export I was just explaining from our primary Jackalope database to our local public database that we get on a weekly basis. And then from that local Jackalope PDB, we are able to create data tables, Oracle data tables and data views through the SDE. Which systems like Tratus Edit tool, if you want to go to the next site, the Tratus Edit tool, like I mentioned in the previous Linework enterprise solution diagram, uses the SDE and all those data from Jackalope, PDB, as well as STN and Whistler and HPMS. We can make a one-stop shop of all those data sets. And I'm gonna I had a recording here. I'm gonna go through one of the tools of the application, and that tool is fixing historical site links. This process happens when STN or Whistler link is updated, and we lose that association between a site and the segment. And the tool at Tratus Edit tool has a tool in it that notifies you which site has an expired link, and it will take you to that, which I will show here in this video. In this, going back previously too, we have two different traffic data, two solutions for the traffic. So we have Jackalope and the PDB or Tratus Edit tool here. So we're combining both, looking at both systems here. So as you can see, you got a taskbar that you can go in and it'll, or here I'm going through the video, I'm showing you the different feature layers available that we can view. And up here we have the taskbar that has different tools available. One specifically is site on historical link. And this gives you a list or notifies you of the sites with expired links. I'll end up selecting one here, and this will zoom you to that site, select that site, and then going into Jackalope site admin, confirming locations. Three 50455, and as you can see up there, it inserts that site ID in that window. You'll want to then select Tratus site at the Tratus site, and determination of if it's a state or a local road is based on what you select there. So we are on State Trunk Highway 86 or 96, that is. So you'd want to select state roads, and it was between those two road names. So I'm going to go in there, search that site, confirm its location text, and longs are included in that as well. So I confirmed its location there, and as it's going between those two, the segment actually changed there. So it was off a segment, now I recall. I'm bringing it back into its correct segment, selecting it, State Trunk Highway 86, and this is where you'll pick its positive and negative directions. Associate the east and west, and click OK. And that will successfully link that point back to its segment. Going through another one here. I believe that was it. Yep. And that would be the end of our presentation.
Questions?
Actually, we need to just do Drew's wrap up. And then I think so far all the questions that I've monitored in the chat window have been responded to. So I think we're doing good.
Okay. So I see we're getting close to break here. I'll try to get through these so you guys can get your questions in. Thanks for waiting with those. So what we found similar between the states, transportation agencies have an enterprise GIS system, and most likely due to the requirements from FHWA and Arnold, the All Roads Network of Linear Reference Data. And that came out in 2014. These tools have been built to manage the line work and manage changes between various program areas. Technology challenges as systems become more advanced, and the expectation is that they seamlessly talk to each other. And the big one here is the commitment to collaborate internally to maintain quality data and line work. When we first started these discussions, it was clear this was going to, the interface could save a lot of time and effort for folks, and they were really enthusiastic. And it wasn't just because they would have more time for solitaire or Minesweeper throwback. It was so they could put those efforts towards other things and other projects and better the DOT and the data. And I think that was really cool to see. Some of you even mentioned, you know, thinking about stuff at night or popping up in bed, trying to fall asleep and thinking of something work related. And I think that speaks volumes to the dedication. It was really cool to see how like really vested everyone was and dedicated to producing the highest quality data possible at their respective DOTs. So some of the things we found unique in Kentucky manages Jackalope traffic data via Exo versus the Jackalope system. In Iowa, they developed an in-house tool to push Jackalope traffic updates to RAMs after phase 3, and their process flow was the only one going in that direction from Jackalope to RAMs. In Missouri, the cross-divisional collaboration is a priority at the department, and they do that to maintain the line work and data changes through quarterly meetings. In Wisconsin, they're the only ones using the Jackalope PDB as the data source for the department's online interactive traffic maps. And also in Wisconsin is location control of the GIS network. That responsibility falls in the same section as traffic in Wisconsin. So I've really been honestly excited thinking about this UI being deployed. I know you all have a lot on your plate, and that continues to grow, but hopefully this will help lighten the load a little bit. And here is the presenter's information and contact information. Thank you very much to all the state DOT presenters. Thank you guys for your attention and listening, and we'll go through the chat questions and open it up for additional questions.
So Drew, mostly all the questions were answered through chat already. There's just the last 3 that we see in the window. Tom Reese, hey Tom, had a comment for everybody that the links on WISDOT's LRS control segment is like a linear datum. And much of DOT's road inventory data is referenced to the LRS link system, including traffic data. Both state and local roadways have this link system. Then there were 2 more questions for WISDOT. One from Christy. Were the TET tools shown in the ArcMap session, were they built in-house?
No, that is before my time. Susie might even know this, but
yes, they were.
Believe they were.
Yes, they were built in-house. I already responded to her.
Okay. And then Margaret, you had a question. Do any of the other states play with temporality when updating their traffic data sections in roads and highways? So this would be for our roads and highways users, this question. Answers are coming into the chat window. Nicholas, we apply dates to when we make changes to our traffic segments and try to maintain history where and when we can.
Hi, I guess what I'm asking is this. Every other data set around ITD is capable of keeping up with the changes as they come in, but because we're an annualized data set and we have to wait until after the end of the year before we can actually publish anything for the prior year, so that we can keep up with HPMS, then we will pull out our network on one date and then we will load it back up on another date, but we will tell it to backcast. Usually we'll tell it to backcast to like the end of the prior year. So it becomes a little problematic with any changes that occur, and we have zero control. As you saw, we had over 2,000 changes last year, and we're already up to 1,600 changes this year on our network. So I'm just wondering if anyone else has tried this. We've found some major pitfalls, but we've also found a process by which we can actually make it work. But was hoping to maybe collaborate with anyone who'd be willing to, talk about it at some point.